If we travel at the speed of light in the universe, what kind of breathtaking scenes will we see? Suppose you are currently on a spaceship that can continuously accelerate, moving away from Earth. As the speed increases, the risk of collision with the spaceship will also increase. Even a collision with a grain of dust can cause fatal damage to the spaceship. Therefore, a gravitational field must be equipped at the front of the spaceship to ensure the safety of our journey. Meanwhile, as the speed increases, the starry sky ahead seems to gradually shrink in our field of vision. To understand this phenomenon, you can imagine that you are driving a car on a highway in heavy rain. The raindrops originally fall vertically from the sky, but when the car is driving at high speed, the rain will hit the front windshield, creating an illusion that the raindrops are falling from the front. Similarly, when the spaceship accelerates, a large amount of light will converge in front of us. This is the strange phenomenon of light aberration. Due to the light focusing in front of us, the brightness will also increase. At the same time, the light behind us will continue to expand, and the brightness will become dimmer. At this moment, the spaceship is passing through a huge space-time network structure. The surrounding space and time are vertical, but as time passes, the light aberration phenomenon will distort the surrounding space-time, making the originally straight grid bend. The field of vision also seems to shrink forward. If we pass by a celestial body at this time, it will look like it is rotating past the spaceship. This phenomenon is the terrifying terral rotation. And if we use a super telescope to look back at Earth at this time, we will see the strange Doppler effect. The movements of people on Earth will become slower and slower, and every second on Earth will take longer to reach us. As the image of Earth stretches, it will eventually disappear from our view. This is because as we move away from Earth, the light emitted by Earth takes longer to reach us, causing the stretching phenomenon. However, at this time, in front of us, we will see the opposite scene. Due to the spaceship constantly chasing the light ahead, a blue shift phenomenon occurs. The starry sky ahead will become bluer, and the speed of the celestial bodies will increase. These are all caused by visual aberration. However, as the speed increases, when approaching the speed of light, it will trigger irreversible physical phenomena. That is the time dilation effect in Einstein's special theory of relativity. Simply put, our universe is a huge four-dimensional structure, composed of three-dimensional space and one-dimensional time. Although in three-dimensional space, we can move in any direction without any constraints, in the four-dimensional structure, all objects must follow the path to the future. Even after the spaceship takes off, it is the same. It will also move towards the future with Earth. But as the speed of the spaceship increases, the spacetime trajectory of the spaceship and Earth will deviate, making their time axes no longer aligned. If we turn back to Earth at this time, we will find that the clock on the spaceship is slower than that on Earth. Meanwhile, as the spaceship continues to accelerate in the universe, it will also trigger the length contraction effect in special relativity. That is, the length of the spaceship will contract along the direction of motion. This is because the universe is moving backward relative to the spaceship, so the distance to our destination will be shorter than expected. This is not an optical effect, but a real physical phenomenon. Simply put, the faster our flight speed, the less time it takes, and correspondingly, the distance to the destination will shorten. It is possible to travel thousands of light years in just a few seconds. But for people far away on Earth, thousands of years have passed. You may find it incredible. To further understand this phenomenon, imagine the spaceship is currently passing through a planet. When the planet approaches us at extremely high speed, its orbit and length will shorten. Moreover, the farther we see, the farther into the past we can see. Because the back of the planet is farther from us than the front, the light emitted from the back takes longer to reach the spaceship. Eventually, from our perspective, the planet looks like it is rotating. This is also the terral rotation phenomenon. Unfortunately, although the spaceship is constantly accelerating, relativity ruthlessly tells us that no object with mass can exceed the speed of light. Even if it is very close to the speed of light, the light will still escape from you at a faster speed. As the speed of the spaceship increases, the field of vision ahead will continue to shrink until it becomes a tiny bright spot, surrounded by a dark space. Although the spaceship cannot exceed the speed of light, in general relativity, the structure of spacetime is actually dynamic. It can bend in various forms. If we install a warp drive around the spaceship, using a gravitational field, we can push it to exceed the speed of light. This is the legendary warp drive spaceship. It can push the structure of space itself forward, like breaking through the speed of light on a stationary space. But for warp drive technology, there is currently no evidence proving its feasibility in practice. Because the antimatter and dark energy needed to warp space may not exist in the universe at all. People can only simulate and calculate its feasibility. If the warp drive spaceship really exists, it will appear out of nowhere in an unknown area, causing the spacetime distortion to deviate from the path of light, forming a moving lens. One part moves forward, and the other part moves in the opposite direction. Moreover, the light it emits may not have traveled 50 before the warp drive spaceship has already passed through us, causing us to possibly receive both the light that has not yet reached us and the light left after passing through. From inside the engine, we will see the space ahead compressed, becoming extremely bright, while the space behind looks completely dark. The entire sky will disappear from our view. Because we are traveling faster than light, the light behind us can never catch up with us, ultimately making the conical region of the universe forever invisible.